All right, nerds. So here we are with our first video and our topic, separations. Now, today's video is just an intro, and we're going to focus on the idea of mixtures with separations. Now, that's where the separation comes from. It's all about separating mixtures apart. So let's go. All right, what's the point? Today, you want to get some vocabulary out of the way so we can learn some of the words you're going to use in your separations topic. And then you're going to work out how to classify mixtures, substance matter in terms of mixtures and pure substances. All right, so pure substances, compounds, and mixtures. What is a pure substance? Well, basically, a pure substance means you have one type of substance. It can be an element or a compound. Here we see an element, and here we see a compound. You can tell it's a compound because there are two things stuck together, or two different things stuck together, and here it's an element because it's one type of thing. That's it. So those are atoms. Now, a pure substance has a constant composition. Okay, so if it's oxygen, it's only oxygen. Never varies. It can exist in three states. It can change. It can go from a solid, liquid, or a gas. Or also plasma, but we don't really talk about that. So solid, liquid, gas. It can exist in all three states. Elements. Now, an element is a pure substance that's made up of one type of atom. Okay, one type of particle. So they can be atomic, like this here. See, it's one type of particle. Or, if you go to this element here, just this one here, not the whole lot, it can be a molecule. You can see there's two there of the exact same atom stuck together. So it's a molecule or atomic. Compounds, on the other hand, can be, they are more than one type chemically combined, which means they can only be compounds. They can never be molecules. They can never be atoms. Because if you've got just one type of atom on its own, it's an element. It can't be a compound. All right, so a mixture. Now, it's made of many different types of particles, and they're not chemically joined. That's really important. So if you look at this one here, this is still a compound, a pure substance. Those two there are chemically joined, but these two, they're not. There's space between them. They're not chemically joined. And you have a variable composition. Okay, so we say air, right? You know, it's made of nitrogen and oxygen and a few other trace elements, carbon dioxide, and that varies. But not a lot, but it does vary. So, if we're looking at mixtures, there are two types of mixtures. There's homogeneous and heterogeneous. You'll see the word homogeneous, and that's not quite where we're going for. You want to make sure it's got that E in there, and they're both different prefixes on the same suffix. So, what does this mean? Mixtures can be separated by physical means. That's the first thing we need to realize. So, we use a physical way of separating, not a chemical way, which means we can dry them out, we can filter them, whatever. Mixtures can be described as heterogeneous or homogeneous. Now, homo means the same, hetero means different. Okay, so let's see if you can work out what that means without going into it. Homogeneous. Okay, so you've got identical properties throughout the solution. Okay, so here's your salt water. You get, because that one's homogeneous or homogeneous, at any different point, it will have the same properties. This is a heterogeneous mixture, it's chocolate milk. Because the heavy chocolate will settle to the bottom, you're going to have a different composition, different properties throughout. So if you get a small sample here and a small sample here, they might even have different boiling points. All right, so homogeneous has the same consistency throughout and identical properties throughout. Heterogeneous has differing properties throughout and visibly different parts. Now, solutions, if you get down on an atomic level, yes, there are differences, but visibly, they're the same throughout, whereas this one, there are visible differences. Okay, so how do we classify them? Well, simple. Pure substances contain only one type of matter, can exist in all three states, and they can be broken up into either elements or compounds. All right, mixtures, two or more substances, simple as that. Now they can be homogeneous or heterogeneous. So this can be, there are ways we break that down even further. So appear to be one substance, homogeneous or homogeneous. Looks like it's two or more different parts put together, heterogeneous. So solutions, mechanical mixtures, which we'll talk about as the topic goes on. All right, how would you classify it? Well, here's our flow chart. You get your matter, and you go, does it have uniform properties? No, it's a heterogeneous mixture. If it's yes, you keep going. Is there a fixed composition in all different parts? No, it's a solution. Yes, we go down further. can you break it down chemically? So if you hit it with electricity, will it change? If the answer is no, it's probably an element. If the answer is yes, it's definitely a compound. All right, that's it. Make sure you get all that down, and we'll see you in class.